Hi, Tony here from College. So we're going to draw a graph that represents the price of a cab ride with Sheldon and Leonard according to the distance of the ride. On the horizontal axis, we have the distance in miles, and on the vertical axis, we have the price in dollars. Let's start with Sheldon. As soon as you enter the cab without traveling any distance, he already charges you $3.50 for the base fee. So for 0 mile, the price is 3.5. This is why we put the point here. This line up corresponds to 0 mile, and this horizontal line corresponds to $3.5. Note that we understand 0 mile here as entering the cab and not covering any distance. We don't understand it as not using the service at all, in which case, of course, the price would be 0. So a situation where you would pay $3.5, $3.50, means that you would enter the cab and leave before Sheldon starts driving. It sounds a bit unlikely in real life, but it could technically happen. Say you enter the cab and just after Sheldon turns the meter on, but just before he starts driving, you realize that you forgot your phone and you have to run for it. This would be the scenario where you would pay $3.50. Anyway, this is our price for 0 mile, and then we calculated the price for 3 miles, and we know that that price is $12.50. So we put another point here. Now that we have 2 points, we can draw a straight line between them, and it will give us the prices for all the distances traveled. So let's draw that line, and here you go. And let's indicate that it is Sheldon's price. Since we already calculated 5 miles and 7 miles, let's check if the graph gives an accurate price. For 5 miles, we had a price of $18.50, and this is indeed what the graph gives us. And we also know the price of 7 miles, that should be $24.50. So this is the line for 7 miles. We indeed get a price of $24.50. A small tangent real quick. We can have equations whose graphical representation is not a straight line, but this is a discussion for another day. So far, all the equations we did correspond to a straight line, and they are called linear equations. End of the tangent. Back to the graph, let's now draw Leonard's line. To do that, we need 2 points on the graph, and for that, we can use any of the values we already calculated. We could even try to calculate a point for another distance, but there is no reason for doing that. We're just going to pick a couple from the ones we already have. Let's go with 0 mile again. 0 mile costs you $6. And for the second point, let's go with 7 miles. We had calculated that the price for 7 miles with Leonard was $23.50. So our point goes here. So let's draw Leonard's line. Here we go. Arguably, the most interesting part of this graph is what happens at 5 miles. We can see that the two lines cross exactly at $18.50, indicating that they charge the same price for this distance of 5 miles. And we can also see that left of this point, it is the green line, Sheldon's line, that is lower than Leonard's line. This indicates that for any distance below 5 miles, Sheldon is cheaper. And then after 5 miles, for a distance greater than 5 miles, it is Leonard's line that is lower. And this indicates what we already said, that Leonard is cheaper for any ride greater than 5 miles. And as we said, these lines are straight. That means that they can cross at most once. This is why we can be sure, even if we don't draw the graph, that the driver who is cheaper for a given lower distance, lower than the distance for which they charge the same, that driver will be cheaper for any lower distance. And similarly, the cheapest driver for a given higher distance will also be the cheapest one for any higher distance. Now I'm going to show you a step-by-step summary of what we did to calculate the cheapest price for any situation. Pause the video and read them carefully. Make sure you understand exactly what they refer to. If needed, rewatch the parts that you're not sure about. It can be either in this video or in the 3 previous ones. Depending on which question you're trying to answer, you might leave some of these steps out. for instance, you might not care about the price you pay when they both charge the same. So you could leave step 2 out. And as I said earlier, this kind of approach can be used in other real-life situations, not only for cab rides. We'll do that in future videos.
Empowermefirst.college is here today.